Please wait. I want to share the screen. I want to share my screen with you. So kindly wait more. Okay. So I'm going to share my screen with you. So let's please. Please can you all see the screen that I've shared? Can you all see it?
Yes, sir.
Hello. Can you all see the screen that I've shared? Okay.
Yes, we
Yes,
can
sir.
see it. Yes.
Okay, fine. Today we are going to take one of the components, and one of the components that we are going to discuss about is the motherboard. That's trying to know what your motherboard entails. So without wasting my time, let's see. Um, I think last week we were able to identify the motherboard. So what do you hope to achieve after today's lecture? You should be able to explain, mention, and the different motherboard components. Then when you see the computer motherboard, you should also be able to recognize it. Then you should also be able to identify the various parts architectures that we have. And so when we talk of that, like I'm still going ahead to identify some of the components. Like if you take the system unit, the most of the front panel, like the system unit, you will see that mostly the modern computer that we have, you will see the USB in front, then you see the audio, the power button, and what do we use the power button for? Yeah, I think that mostly the power button is usually found on the front panel so that you can what? You can power the system on. So mostly if you want to put the computer on, you have to put your hand on the power button. Yeah, if the system freezes to up on you, you may have to also power off with what the system and then on with what with cold booting. So you can use the power button to also put the computer off. So, what then is the cold booting? Yes, that a cold boot is what when you shut off the computer and then power it back on by using what we call the power button. And we have the power light. Sometimes when you are using the computer, mostly you usually find what the power light on the front panel so that you can tell whether the system is running. So mostly you can see that when the system is busy, you can see some yellow or some red or something. And we have what we call the drive activity what light. The drive activity light will flash when the system is busy. So mostly when the system is busy, you can see that the power button, you see that there's what the flash activity light that will hot. And we also have what we call the reset button. But mostly the current computers that we have, we don't have the reset button. But the olden desktop, we need to have what we call the desktop. So some systems come with what the reset button, which is used to do what we call the warm booting. So there's difference between what cold booting and what warm booting. In computing, we have two types of what booting: warm booting and cold booting. So the warm booting is when the computer is what already running and it needs to what to be restarted or rebooted. So maybe sometimes you are using the computer and it's running, but you want to restart the computer. If you do that, we see that that one can be classified as what as a warm boot. And we also have what we call the cold boot. So the cold booting is when you shut off the computer and then you power it back on by using what we call the power button. That one is what we call the cold booting. So if you look at it, this is the olden desktop where you can see most of the things that we are talking about: the reset button, the power switch. We have the USB, the DF, the DVD, the microphones, and the mic and the ports. All those there for you to look at. So we are going to take the activity for the day. One, we talk of the motherboard. The motherboard. And then when you look at the motherboard inside your computer, what you see that you will notice that the number of different items that are connected to it. So most of the how do I say most of the items that we have connected to the motherboard. So in this session, what are we going to do? We will be able to identify the different components that are interconnected through what? Through the motherboard. So one of the components that is connected to the motherboard is what? Is the processor. One of the components that is connected to the motherboard is the processor. And we are seeing that one of the easiest items to identify on the motherboard, when you take your computer motherboard, one of the things that you'll be able to identify on the motherboard is what we call the processor. And the processor, we've already established the fact that it is known as the CPU. We can also call it the central processing unit. And we have to also note that the processor is also regarded as what as the largest chip on the motherboard. There are two chips on the motherboard, but the largest chip in the motherboard is the processor. Please, somebody kindly keep your microphone off. It's giving me a lot of feedback. So please, can you hear me? Hello.
Yeah, yes, sir. We
Hi.
can hear you.
Yes, sir.
So
Yes, sir.
we are saying that the largest chip on the motherboard is what? The processor. And on the motherboard, and also it's almost like once we talk about the processor, then we'll talk about the heat sink or the fan on top of the processor. Anytime you see the processor, you will see the heat sink on it. And the reason why we have the heat fan or the heat sink on it is to cool the processor, because the processor generates a lot of what? Heat, a lot of heat. So this is a typical motherboard that you can see. And you can see the processor on the motherboard. So the largest chip on the motherboard is the processor. Okay, we are seeing that the motherboard also has a socket that the processor is inserted into. So which means that if you take the motherboard, the processor is also being put into what? A socket. How do we put the processor into that socket? We are saying that we put the processor into the socket by using what we call the zero insertion force. The zero insertion force. That's in short we call it what? The zip socket, which means that the processor chip can be removed or added to the socket with very what? Little effort. So anytime you want to install your processor onto the motherboard, you are going to do this with what? With the zero insertion force. The zero insertion force means that you are just going to put the processor inside the processor socket, then you press the lever. We don't use all our strength to press the lever, but what we do is we just use your hand to press the lever, and you see that with zero insertion force, that it will be what? It will be installed for you. So the zip socket typically have what we call the lever. So you put what to pop out the processor out of the socket. So what you do is that anytime you want to pop out the processor, you just pull the lever and it will pop out the processor out of the socket for you. So this is what we are talking about. This is the zip, the lever that we are talking about. You can see the lever over there, the picture that I've shown to you. And that's what we call the processor socket on the motherboard. So that's where we put the processor. Then after that, you just press what? The lever. You are not going to use any force. Well, the force that you are going to use is zero insertion force. That's what we call the zip. So a zip socket on the motherboard, with that you are able to install the processor. Why? Because if you use a lot of force, you are going to break the pins on the processor. And once you break any of the pins on the processor, then which means that you spoil the processor outright. Then the next thing is what? When we do this, we used to have what for the Pentium 2 processor that it was developed by what? Intel. It was having what we call the single edge contact. In short, we call it what? The SEC. So motherboard had to implement different type of sockets, and that's known as the slot one and so on and so forth. But now this socket is no more. We have the Pentium socket because we have moved away from the Pentium era to what? To the I series. So we are no more using that socket, that's the Pentium 2 using what? The SEC packaging. So back when we were those days, we were using it. So this is a typical motherboard that in the old days that was using what? A Pentium 2 with what? A Pentium using what? The SEC packaging. So that is that for you. And we also have the socket 5 and all those things. These things, they are no more in the market. They are out of the market. So they are not going to waste time over there. So classic Pentium chips, they were inserted in what we call the socket 5. and socket 7, whereas Pentium 2 processors were inserted into what we call the slot 1. But yeah, the Intel has moved away from that set era where we used to have the Pentium based, and now they are developing what? Because we have the new processors, that's the I series, I1, I2, I3, I4, we have moved away from that set era. So Pentium 2 is placed in the socket what 370, and Pentium 4 is also placed in socket 423, and so. But please, all these set technologies, they are out of what the market. So when we talk of the processors too, yes, there are two general types of mountings that is used to connect the processor onto the motherboard. We have the socket and what the slot, the socket and slot. And some processors are available in only one mounting type, and that is the Intel Celeron. And we have, and they are available with what both types of what mountings. And we have the types of sockets that we have. We have the socket 0, socket 1, socket 2, up to socket 8. Then when we look at it, we are saying there are four types of what slot mountings that is used to attach microprocessors to the motherboard. So we have the slot 1 and the slot 2, the slot A and the slot M. So look at the processor socket. We have the CPU socket and the slot. So we can see from here the picture that I've shown on the screen. You can see the CPU socket, and also we can also see the CPU slot. And these are some of the things. Please take your time and look at it. And when we talk of the processor too, we are going to talk about what we call parallel processing. That uses what multiple processors simultaneously to execute what a single program or task. We have what we call the parallel processing, and what it does is that it massively parallel processing involves hundreds or thousands of what processes. So when we talk of parallel processing, it uses what we call multiple processes simultaneously, that is at the same time, to execute single program or task. So we have the control processor, that is so we have processor 1 with one memory, processor 2 with another memory, and processor 3 with the memory, and processor 4 with the memory. So when we do that, we are implementing what we call the parallel processing. When you combine the results, the output that they are going to take what fast, the processor is going to process fast. Then we also have what we call the memory socket, or sometimes we can also call it the memory banks. They contain the actual memory chips. They contain the actual memory chips. It is easy to identify. It is easy to identify on the motherboard. And in terms of the memory chips, they are usually white and 3-inch long, and they are placed very close to each other, very close to each other. And so the number of memory slots varies from motherboard to motherboard. The appearance of the slot is also very similar, very similar. So memory types have changed throughout the years. So if you look at this, some of the memory slot types that we have the SIM, like the single inline memory model. Then we also have the dual. So when we talk of the single inline memory model, it has pins on both sides of the model. That's it has pins on both sides of the model, but the pins are they are redundant on on both sides. And the single inline memory module it's also having what we call the 30-pin slot. It's also having the 30-pin slot. And they were shorter and typically used in laptops, while the 64-pin and the 72-pin slot were also found on the desktop motherboard. So the same RAM had to be installed at an angle. That's you push upright into place. Anytime you want to install the memory, you always push it at you install it at an angle, then you push it upright onto into the place that you want to put it. And there is also what we call a notch on both ends of the memory module. That is, it is having a clip by arms on both sides. It is needed to be installed in identical pairs. Anytime you want to install it, you also install it in identical pairs, no mix and match. So the two slots that the pair of SIMs go into is what we call the memory bank, the bank where you install the memory. We call it the memory bank. So you can look at this. This is an example of the single inline memory model. So I've shown you a picture. If you are still confused, you can go to Google Images and put this thing over there. It will give you a lot of images for you to appreciate it over there. So we have the single inline memory model. That's the picture for you. Then we also have what we call the dual inline memory model. That's the socket. That dual inline memory usually is having what 168 pin 3-volt unbuffered, and it is synchronous what pin, and it is found in all newer Pentiums. Now we don't have the Pentium processors. So this type of memory can be installed at one stick at a time. You can install it at one stick at a time, and it can be often be matched with what different types of what pins, different types of pins for you. And as I said, most motherboards offer 2 or 3 or 4 DIMM slots. Most of the motherboards, the current ones, offer this 2, 3 or 4 DIMM slots. So the slots are hot. The slots are the slots are what DIMM goes into should be marked on the motherboard as what in 0 and so on and so forth. So usually the motherboard has having, so this is example. That's example of what the dual inline memory model. The dual inline memory model. So that's where this is on the motherboard. So you can take your memory model and you slot over there. So that's what we call the dual inline memory model, and it's also found on the motherboard. If you look at this tool, we have the single. If you are confused about the memory chips, I've shown you the picture over there. So the single inline memory model, you can see that it's having a single inline, single line for each, and it appears at both sides. But when we talk of the dual inline memory model, you can see that it's not, you can see the difference. If you look at the picture, you can see the difference for you. So please, if you are confused, just go to Google Images. Please, I'll take it for Google Images. Then it will show you. And they are all in the market. So we have the single inline memory model, and we have the dual inline memory model for you. Then after that, we also have what we call the RAM. That's the Rambus inline memory model. The Rambus inline memory model. And that these slots, they were physically similar to the DIMM slot. So every slot on the motherboard had to hold what we call the RAM form, what we call a working memory or bank. So let's look at it. So this is a picture of what of the Rambus inline memory model. So if you look at the RAM, that's the Rambus inline memory model. This one, I think this is the current one, and it's also good. And you can also look at that for yours. Then we also have what we call the SODIMM. The SODIMM. And the SODIMM is also a small outline inline memory model. We usually use it on what? On the motherboard, on the laptop. Most of the yes, sir.
Sir, yeah, please, I just want to notify you. Sometimes we do raise our hands so that you'll give us attention. We don't want to be dragging you backwards.
If
So,
you raise up your hand,
kindly, yes.
I'm not looking at the screen. So anytime you want to have,
Oh, so I can go ahead and talk.
yes, you can go ahead and interject.
Oh, okay.
Sir,
Thank you.
sir,
Thank
please, I
you very
want to
much.
ask a question. I'm moving fast because I want to move to a different section. I have to go to some place. So sorry for the sorry.
Oh, okay. Yeah.
If you
Yeah,
have a
it's in
question.
order. But then, yeah, I just want to find out in terms of efficiency with this, the rim, the DIMM, and then the SIM, especially the SIM and the DIMM, in terms of efficiency, because they actually look similar, even though there are some slight difference. But I want to find out whether in terms of efficiency, we have one which is in upper hand than the other. Thank you.
So if you look at this in terms of efficiency, which one will you go for?
Well, if I'm comparing the two, the SIM and the DIMM, I would rather go for the DIMM.
Why will you go for the DIMM?
Because the dual means maybe it is twice the SIM. That is what I'm thinking.
That's what you are thinking. Please, class, do you all agree with what he's saying? If somebody having a different view, if somebody having a different view, hello, if somebody having a different view from what he said. Okay, so let's move on. If you don't want to talk, that's why I want to do my talking and go. Because if I want to engage you, nobody wants to talk. I want to make the class interactive, but once you want to make it interactive, you are also going to delay. Nobody will talk. So
Please,
yes,
please, want to talk, want to listen to what you have to say. You know,
what I want to
he
say is
said,
that I'm not looking at this. Please, I'm
Hello?
listening to you. So talk. We are listening to you talk.
Yeah, these days machines, like the smaller gadgets or machines are those of even my quality as compared to the larger ones or the bigger ones. So for what he's saying, I may also support what he's saying because these days most of the smaller distance are those.
And most of the current motherboards, they are coming with the dual inline memory model, not the single. The single inline, that one I think is out of market. Now, if you go to the market and you want to buy memory, you are not going to get the single inline unless maybe it's for an older machine. But the current computers and the best of that are coming, they don't come with what that are coming to the market, that manufacturers are putting to the market is not the single inline. They are going for the dual inline memory model. Then we also have what we call the sodium. Yeah, you see the sodium. If you open your laptop, the memory that you have in it is mostly what we call the sodium. We have the micro sodium and the actual sodium. So it's mostly the laptop memory. If you have, you call it what for sodium or the micro sodium. If you can look at the picture on the screen to access that for yourself. So if you look at the desktop complete memory and the laptop memory, they are different. You see that the laptop memory is quite what smaller, and the desktop is what is a little bit bigger than the laptop the desktop. So please get to know the difference. I've shown you the picture on the screen, and I think most of you, wherever you are practicing, you have seen some before. Once you open your laptop, the memory that you have in it is for the sodium or something. In computing too, we also have what we call the cache memory. The cache memory. On top of the memory, we are talking about what we call cache memory. And I think some of these things you've heard about it before. What is the purpose of the cache memory? That's that the cache memory, what it does is that it increases what performance by storing what frequently used program code or data that can be what later accessed by the processor. That can be later accessed by the processor. So the main purpose of the cache memory is to help you ensure what we call efficient, also give you easy and what near instant data retrieval. So if you have a laptop or a computer that is implementing the cache memory and you have a computer that is also not implementing the cache memory, what happens is that the computer with the cache memory will be extremely faster than all the computer without it. So cache memory is what is much what a faster memory than what the normal RAM. As a result, it is more expensive. So that's why if you want to buy a computer that's having the cache memory, the one that's not having, you are seeing that you can see the difference. So that one is so good for you. So why is cache needed? Why is this cache needed in our laptops or in our computer? You see that the cache memory is required to balance what the speed mismatch between what the main memory and what the CPU. So sometimes what the cache memory does is that it helps you to balance what the speed mismatch between your main memory and what the CPU. Why? Because the clock of the processor is very fast. The clock of most processors that we have in the market is very fast. Whereas what the main memory access time is comparatively what slower. So because of that, hence what should we do? The processing speed depends more on the speed of what of the main memory. Therefore, integrated cache is what is the cache memory that is built into the processor. And we also have what we call the non-integrated cache, that is also known as what the external cache is also built outside the processor and typically mostly on the motherboard. So when we talk of the cache memory, we have levels. We have the level 1 cache, we have the level 2 cache, and the level 3 cache. So the level 1 cache mostly is integrated within the processor and it is extremely fast and small. And we have the level 2 cache. That one is also called, mostly we call it the external cache. And the L2 cache may be embedded on the CPU sometimes, and it can also be on what separate chip or core processor. And the L2 cache is used to catch recent accesses from the processor that were not caught by the L1 cache. And we also have what we call the L3 cache. That one is what is specialized memory that is developed to improve what the performance of L1 and L2 cache. So the L3 cache is significantly what slower than the L1 and the L2, but larger. So the L3 cache is what is double speed than the RAM. So please, this thing is not anything difficult. So you can see that diagram that I've shown you, we have the CPU and the main memory, and you see that L1 cache is mostly closer to the CPU, and it is faster. And we have the L2, so closer to the L1 cache, and we have the L3 or cache. That one is what less and faster. We have the flow or something, so you can see the type of what cache memory that we have. But mostly the L1 cache is mostly closer to what to the CPU, and it is the fastest. And someone that you can also follow it, the L3 cache and the L2 cache, and the L3 cache is quite slow because it's not closer to the CPU, it's closer to your
Sir, please, I have a
memory.
question.
Look at that
Sir,
assessment.
please, I have a question. Please, I
You
have
said
a
what?
question.
Yes, ask your question.
So,
sir.
how then would
Please go ahead and ask
how
the
then would
question.
you be able to know if this device has a cache memory, and how would you be able to determine as whether it is level
Aha.
1, level 2, or level 3?
Mostly, if you are going to buy your laptop, we have what we call the manual. Can you see the manual for it? Hello.
Yes, sir.
Any gadget that you want to buy, you see the manual.
Yes, sir.
Please, they state in it. They state in it, or sometimes even if you look at it, they state everything in it, whether this thing is implementing L3 cache, it is implementing L2, or it is implementing both or something. So you have to know. And sometimes you need to look at the price that they are giving to you. Because of that, they will add that as part of the price. So there are different laptops, and it comes to a different pricing mechanism. So it is these things, these parameters that they use to price your laptop. Currently, the laptop that I'm using to do this lecture, it implements what we call the L3 cache, L3 cache, and that is what I have on my laptop. So can you see that? So please, you have to know it. You see, most of us, we are naive users. You just go in and buy the computer, you are using it. Even you ask somebody, what is the processor speed of your computer? No, but a lot of even computer science and IT students, most of them don't even know. They can't even tell you the processor speed of their computer. But please, you have to get to know some of these things. After going through this lecture, you shouldn't be a naive user. You have to know whether the computer that you are using is implementing any of the cache system for you. Are you okay with me?
Yes,
Hello.
sir, we
Hello,
are
are you
fine.
okay?
Yes, sir.
Yes, sir.
You can check your computer. Most of the computers or the laptop that you are using, they are implementing what we call the cache memory. There are some laptops you won't want to copy something. You not even see that it is copying, but before you say that the thing is on your pen drive or whatever you are, because the speed is very fast and there is no speed mismatch between the main memory and the processor. Because if it is implementing the L1, L2, L3 cache, that laptop will be extremely faster. Then we have the motherboard chipset. When you take your motherboard, on top of the motherboard, it's implemented what we call there are two chips on the
Sir,
motherboard. Yes.
yeah, sorry to take you, but I just want to find out with the cache memory that we spoke, the level 1, 2, 3. So that means every computer CPU has got these 3 levels of cache memory embedded in it. Is that what we are trying to say?
Please, it's not every computer. It's not every laptop that's having.
So some have level 1, some have up to level 2, some have level 1, 2, 3, all of them.
It depends on what the manual. They will tell you that this computer that you are buying is implemented what maybe level 3 cache or the level 1 and the level 2. There are some that will tell that they implemented all the cache. And if they have implemented all the cache, that computer will be extremely expensive. So that's why if you go, they'll tell that this laptop 3,000, this laptop 4,000, this laptop 8,000, some 15,000. Oh, hello.
Yeah.
You take your time and ask them the reason why they are selling that particular laptop 15,000 and this particular laptop 4,000.
Sir, please, I want
Please,
to also
how do
ask,
you check?
is there any command for you to check those catch?
Yeah, there should be, but as of now, I don't know, but there should be. You can go there to the system and check whether which of the caches that is using. And sometimes even they put it as a sticker on the computer, like my own is Acer. They have put it as a sticker on the laptop, and it is telling that it is implementing what you call the L3 or cache. The speed of my laptop is what 1.7 gigahertz, and so on and so forth. So sometimes even they paste it, they use a sticker and paste it on the motherboard or something. So there's a way to check it. You go to the properties and check. Hello, can I move on?
Yes, sir.
Yes,
Yeah,
sir.
yeah, to everything. So whilst you're reading, you can also check and see if you want to check that whether it's having that. There's a way to go about it. But so on the motherboard, we are saying that we have two chipsets. We have the north bridge chip and the south bridge port chip. So a motherboard chipset is what? It's a chip formed from what? A combination of what? Various computer chips that hold the logic of what? The controllers. So there are two chips, and the first chip is what? We have the north bridge and the south bridge. So every computer motherboard that you take, it is divided into this two. We have the north bridge section and what? The south bridge section. So when we talk of the north bridge chip, the north bridge chip is what is responsible for what communication from what from the CPU to the memory, and the CPU to what the PCI Express bus and advanced graphic port. And the south bridge chip is also responsible for communication between the CPU and other devices such as what the PCI, the USB, and the ISA or the IDE devices. What we have to also take into consideration is that these two chips contain the bulk of what the logic that allows the CPU to communicate with what other devices. So I'm going to show you a picture for you to see this one. So the north bridge chip is responsible for what communication between what the main memory, the AGP, and the CPU. And the south bridge chip is also responsible for the communication between the PCI and the ID. So if you are confused, sometimes they ask you the difference in exams and you can't write, you can draw this diagram and it still explains it for you. So this is the relationship between what the CPU and the motherboard chipset. But you have to know that we have two, the north bridge and the south bridge. So how can you locate this north bridge and the south bridge when you take a typical computer motherboard? And sometimes it can be challenging, but it shouldn't be challenging at all. Any motherboard that you take is going by that logic. So how can you locate it? If you want to locate the north bridge chip, you know, the north bridge chip is regarded as what as the second largest chip. You see, at the onset of the lecture, I said that the largest chip on the motherboard is the processor. And we are trying to also establish the fact that the north bridge chip is also regarded as what as the second largest chip after the processor. Please, so don't get confused about some of these things. And also typically contains what we call the heat sink or something. The north bridge chip is typically located between what the processor and the AGP slot. So when you take a typical motherboard, when you take a typical motherboard, it's like the north bridge chip is typically located between what the processor and the AGP slot. The north bridge chip is located between the processor and the AGP slot. And the south bridge is also normally what located far away from what from the processor. That is usually it is beside the PCI slot. And so if you look at the picture that I've shown and the motherboard that I've shown on this thing, you can see that the north bridge and the south bridge is on what and an open motherboard. So if you look at this, so the north bridge is what is always closer to what to the processor. So once you take your computer, the chip that is closer to the processor is regarded as what as the north bridge chip. And we also have the chip that is also far away from the processor. And look at this chip is usually what beside what the PCI slot, and that one is what we call the south bridge chip. The south bridge chip. Please, so let's get to know that. What are the functions of the north bridge and the south bridge chips on the motherboard? What are the functions? The functions of what? The north bridge and the south bridge chip on the motherboard. You see that the north bridge chip, it handles communication to what? To the high speed buses such as what the memory, the AGP, and the PCI Express. And the south bridge chip also handles communication to all other motherboard components such as what the USB, the PCI, and the IDE, or sometimes the ISA devices. So these are the functions of what the north bridge and the south bridge chip. So please, let's get to understand some of these things. Please, are you okay? Any question on that? On the chipset? Any question on that?
I said so. I think there was a slide that displayed that showed that the north bridge is under the heat sink. Under the heat sink. I don't know that. Please, if can you scroll to?
So I
Can
didn't
you
say
scroll
that
to?
the north. I didn't say that the north bridge is under the heat sink.
Please, I think it was in the slide. Can you please
I said the north
yes.
bridge chip is typically what the second chip, the second
It
largest chip after.
contains
It contains no after the processor. So I was talking about I was referring to the processor, and also contains the thing on what, or a fan on top of what the chip to make it what cool. To also make it cool. Yeah, sometimes. So that is what that I was referring to the processor for you. Sometimes there are some of the laptops that can contain that for you, but this laptop that this motherboard that I showed you, there's no heat sink or something on it to make it cool for you. Please, are you okay with that? The north bridge and the south bridge chip. Please, are you okay with that? Can I move on?
yes, sir.
But you please mute your microphone. It's giving me feedback. Kindly mute your microphone. So after identifying the types of motherboard, so we have been able to identify that. So, oh, who is this person? Please mute your microphone. Kindly mute your microphone. Who is this person?
Seth Daku, please help us.
Set Daku, please set Daku or something. Mute your microphone. You are giving me a lot of feedback. Okay, identifying the types of motherboard. So we are saying that we are going to look at what we call the types of motherboard. So the motherboard, we always talk about what we call in computing. We mentioned something we call form factor. A form factor. So when you say a form factor, is that a motherboard form factor describes what the dimension of the motherboard and the layout of the motherboard components. So the motherboard form factor describes what the dimensions of the motherboard and the layout of what of the motherboard components. So basically, we are saying that there are two commonly known form factors of the motherboard. And we have the AT and the ATS. So we have the full AT and the ATS. So in computing now, when we talk of the types of the motherboard, you either have the AT laptop or the ATS laptop. So the ATS motherboard or the AT motherboard. So that's what we have to get to know that. And I think what is the current? Who can tell me the current one? Is it the AT or the ATS? The current one. Is it the AT or the ATS?
ATS.
Okay. ATS. So in the AT family, we have the baby AT, we have the ATS, mini ATS, we have the micro ATS, and the flexi what ATS. There are different what variants or that are available in the AT family. So what you need to also understand is that the different motherboard form factors, the form factors, because you can't just take any motherboard and place it in any computer case. Yes. So for example, you must put what a full AT motherboard into what a full AT case, and the baby AT board also in the baby AT case, and the ATS board in the what ATS case. So we have the figure one shows what the full AT motherboard. So we have the baby AT motherboard and the ATS motherboard. Looking at what different motherboard what form factors. So these are the pictures. You can also go to Google Images and search for
Sir,
more of the yes.
sir,
Please, I'm listening to you.
please, do we have any type of motherboard called Jota board or something like that? Jota board.
Daughter board or Jota.
I think
Hello.
we need
Are you talking about daughter board?
Yes, Jota board. Jota
Yeah,
board.
yeah. So maybe per adventure, maybe I have my computer and I want to use the computer to watch TV. What I have to do is I have to go and buy the TV tuner card. When I buy the TV tuner card, instead the TV tuner card itself is also having a board. I have to go and slot that TV tuner card on the expansion slot on the motherboard. So it's like that TV tuner card board will act as a daughter board to the main motherboard of the computer. So that's why we see that sometimes we have some of the board that act as a daughter board to the main motherboard. Are you okay with that?
Okay. So when you buy a video, and what of a network card? You
Yes.
slot a network card.
Onto the motherboard. So the card is also having so that board will act as a daughter board to the main motherboard. Are you okay with? Okay,
Yeah, I understand.
Okay, fine. Let's move on. Okay, so when we talk about the full 80, the full 80 motherboard is 12 inches wide and 11 inches long. It has only the keyboard connector, and in the back and on the back of the motherboard, you can see that this full 80 motherboard is out of the market and it contains no other input or output port. So the full 80 suffers from a problem with accessing some items on the motherboard because the drive base hang over the motherboard. So that's what we call the full 80. And so please, this is no more in the market. I can boldly say that we can't find this full. So this configuration makes installing and troubleshooting motherboard components very difficult. So another problem with the layout of the full 80 board is that the expansion cards, after having been inserted into the systems, cover the processor. So this situation leads to what we call the cooling problems because of ventilation is insufficient to keep the chip from overheating. So please, this full 80 motherboard is out of the market and we have moved beyond that. So this is a typical example of the full 80. Then we have the baby 80. The baby 80 motherboard form factor had also been one of the most popular motherboard types until recent years. So the baby 80 is also 12 inches long and 8 inch something. It usually has what we call the DIN, and this one is also out of the market, so I'm not going to waste time over there. The keyboard connector on top of the upper right corner of the motherboard. So the baby 80 motherboard is about 2/3 the size of the full 80 board. And so let's look at that. So this is a typical baby 80 motherboard, which currently I doubt if this motherboard is also in the market. Let's consider some of the key components on the baby 80 motherboard. You can see the zip socket or the zip slot at the bottom of the motherboard. Also, you can also notice the SIM and the DIN socket on the right side of the motherboard. This is the motherboard that we are talking about. So when I send the slides to you, you can also refer to it whilst you are reading. Then to the left of the SIM and the DIN slot are the primary and the secondary IDE connectors, and to the left of the IDE controller and all those. So please, if you want to take your time and go through it. Then we also have the LPS and the NLS, the LPS and the NLS. So that one is also after the era of the baby 80 came the era of the low profile extended and the new low profile extended motherboard. So both motherboard types serve the same purpose to create low profile computers also for you. So this is also a typical example of the LPS, the N and the NLS motherboard form factor for you to see. So the NLS motherboard is identified. Please, I'm going fast because some of these things I'm not sure I'm going to examine you over there because they are mostly out of the market. But at least once you have that computer hardware, you should know the genesis of how we have come all these files. So please forgive me if I'm going far. Then we also have the ATS motherboard. So what happened is that in 1995, Intel wanted to work. Intel wanted a motherboard that would support the Pentium 2 processors and the 8 GB slot. So the ATS form factor was built. So which means that the ATS current computers now they are using the ATS motherboard. So you see that Intel started this somewhere in 1995 when we are still in the ATS era. And when they started it, so the ATS board as at that time was 7.5 to 12 point something inch, and it has most of all the input and output integrated directly into the board, including the USB port. So this is what the picture for that for you to see. Then this is a typical ATS motherboard. So this the ATS motherboard is what is very popular in today's system. So today, as at now, most of the motherboard that we have in our computers, they are what? They follow the ATS, they are ATS. So please let's get to know that. So you should notice for what? For instance, slot one where Pentium 2 chip can be what inserted. Pentium 2, we have moved from the Pentium era to. Then you also notice on the top right corner where the values chip with what? With the white label on top of it is also located. And at the top of the figure, you can also identify the IESA and the BCI slots and so on and so forth. Then we also have what we call the micro ATS and the plus what ATS. The micro what ATS and the plus ATS. You can see that the smaller version of the ATS motherboard are the micro and the plus. So the micro motherboard form factor is 9.6 to 9.6 inches, and it can fit in either the micro ATS case and the normal ATS. So we have the plus ATS, it's also smaller than the micro ATS that can also fit in what in the ATS or the micro ATS case. So the Flex ATS motherboard form factor is also having this dimension. So what we have to also take into consideration, what we have to know is that the Flex ATS is not as popular because the size of the motherboard limits how much you can expand the system. So this is a typical example of what the micro ATS and the Flex ATS motherboard for you to see. So this is a sample picture that you can also look at that. Then we also have what we call the ITS. And so if you take your mobile phone, the board in your mobile phone is also known as what the ITS. So the ITS motherboard form factor was developed by what the IA technologies and comes in what different form factors. So mostly what you see that we use it in what in the mobile phones. So mobile ITS came into somewhere 2009 and it's used to compact devices and we use that in what in our mobile phones. So these are types of motherboard form factors and the various types. So please, whilst you're reading, take your time and go through that for you. So IBM started and you came to the 80, the baby 80, the LPS, the micro 80, you came to the ATS, we have the mini ATS, the mini LPS, and so on and so forth. So this is how far the various form factors of the motherboard has come. So please, whilst you are reading, want to take your time and appreciate those values. Okay, if there's no question, any question on that dimensions, the form factors of motherboard, what we have to do is that we have the full AT and the ATS, and the current one that we have in the market on the market is what the ATS motherboard. Any question? Any question? Any question?
Please, sir.
Okay, if there's no question, then we are going to.
I wanted to find out the full meaning of the ATX or my network to some point interrupt. I don't know whether you explain that one.
You want to find the full meaning of the. Who can tell him the full meaning of the ATS? Means you are in the university. He said you want to find the full meaning of the ATS. Hello. 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 Hello, are we there?
Hello. Yes,
Please
please.
go and check that for yourself because you are in the university and you are doing first degree. I can't teach everything. So if you are learning, check that for yourself. Go to AI or go to Google and you get the
So
full meaning
it's
over there.
advanced
Okay,
technology
please, are you
extended.
okay with that? You should know that because you can't teach you everything. You are learning this and you want to know what the full meaning of 8 years. So you have to know this. Boss. Some of the questions if you ask is basics. Um, when you know you need primary school.
Please,
Okay,
I understand, no, but most of the distance you are showing up, they come with also full meaning. For example, the bio, for instance, on the screen. So that one, you only wanted to see if the full meaning is there, and not that we just rely on
but
solely on
if I
this thing
don't
to
break,
give us full meaning. But
don't,
most of the
don't,
distance come with
don't
their
worry, don't
full.
worry. Okay, sorry for that. But anytime you are looking on the slide and you are not seeing the full meaning, you can check it for yourself. Okay, you can check that for yourself. Okay, so we have the BIOS chip also on the motherboard, and the BIOS in full we call it the basic input output system. We have the basic input output system. That's the BIOS, and the BIOS is what is regarded as the low level program code. The low level program code that allows all the system device to communicate with what one another. That's the basic input output system. So this low level program code is stored in the what in the BIOS RAM or chip on the motherboard. So the BIOS chip, one were those days when computing started, was regarded as what as a read-only memory chip, which means that you can only read information from the chip, but you can't write to the chip under normal circumstances. But now it is not so. Most of the BIOS you can write to it. Yes, most of the BIOS, the current computer that are coming, you can update your BIOS. And when computing started, you can't write to the chip, but now it's not possible. You can write most of the BIOS, you can take it and update it with what your current information. So as I said, today's implementation of the BIOS chip, we have what we call the EEPROM. That is the electrically what? It's an erasable, programmable what? ROM, which means that you can what? Get special software from what? From the manufacturer of the BIOS to write what that chip. So mostly the current BIOS that we have, you can write it. So the question then is, why would you want to erase the BIOS? Why the manufacturer have put something in the BIOS, but why do you want to erase it? So maybe suppose, for example, that your BIOS is programmed to support a hard disk up to 200 gig inside, but that you want to also install a new larger hard disk. What will you do? What can you do then? What you have to do is that you can contact the BIOS manufacturer and get an update for your BIOS kit, which is usually what a software program. In the past, what you can do is that you generally have to install a new chip, but now you can do an update. So as I'm running the software program, writes what a new instruction to the BIOS to make it what aware that there are hard disks bigger than what the 200 gig, and it provides instructions for what dealing this time. Okay. So we have what you call the BIOS chip and the boot process. The BIOS is very important, and the BIOS chip contains the code that controls the boot process for your computer. And by now, when we mention booting, you know, as it's already established, and we have warm booting and the cold booting. So it contains the code that will perform what the power on self test. The power on self test, in short, we call it the post. So post means that the computer goes through a number of tests, checking itself out and making sure that it is okay. So if any computer fails the post, what happens is that after it makes it past the post, the BIOS then locates what the bootable partition and calls on the master boot record, which loads the operating system for you. So we are saying that anytime your computer fails what the post, that computer will not boot. So what happens? What happens is that we are saying that after the computer makes it pass through the post, then the BIOS locates what you call the bootable partition. And that bootable partition, mostly we call it what the master boot record. And that master boot record is responsible for what? Loading the operating system for you to see. So let's see the BIOS chip and the boot process. So let's see. So please, are you okay with that? Any question on that? Are you okay with that? Hello. Hello, are you there? Can you hear me?
Yes, sir.
Are you okay
Yes,
with the
sir.
BIOS?
Yes.
Yes. Okay, fine. We are moving on to the next component that we can also see on the motherboard is what we call the CMOS battery.
Okay.
The CMOS battery. Hello. Please talk. If you have a question, talk. Please, if you have a question.
So I want to ask about the slide, but hello? Hello?
No. Hello, please talk. I'm listening to you. Please talk. I'm listening to you. Please, if you have a question, I'm listening to you. Ask. Please, somebody was asking a question. Yes. Hello.
Hello, sir. It wasn't a question. I wanted to ask about the slides, but since someone have shared it to the main group.
The second slide. Yes. After that, I'll
It's
send
in
it to
the
the
first
course.
one that I'm seeing where lecture.
The first one. Okay. After this, I'll give this to the course.
Okay. But we have.
You have it already.
So we don't have it on the main page. Some of us are in a different groups. So if you can get to the main page,
Okay, so we have
help
what
us
we
so
call
that
the CMOS.
some of us can have access
We
to
have
it.
this. I'll send this to the course rep, given to you, so don't worry at all. And we have the CMOS battery. So we are saying that this the computer keeps track of what is inventory, and what are some of the inventory that the computer keeps track, and that inventory is known as what the full meaning of what the CMOS is what complementary what metal oxide semiconductor. So the CMOS holds what a listing of what the system components, such as what the size of the hard disk, the amount of RAM, and the resources. So what happens is that this inventory list is stored in what we call the CMOS what RAM, which is a bit of a problem because the RAM loses its content when the computer is shut off. So to prevent this sort of problem, what happens is that a small watch battery is like the wristwatch battery on the motherboard maintains enough energy that the CMOS RAM don't lose it don't lose its charge. So what happens is that's example of what if you look at the typical motherboard I've shown you, this is the CMOS battery for you. And one purpose of the CMOS battery is that it also holds the date and time. The date and time. So if you look at the date and time on the screen, it's being held by the CMOS battery. Who can tell me the reason why?
Please, your question again.
Yes, why do we have the CMOS battery? I said it also holds what the date and time. Why do we have the CMOS battery? Yes,
the CMOS battery. Yeah,
yes.
it saves the system settings.
It saves the system settings. Okay. The settings like what?
Hello, sir.
Yes, sir. I'm listening to you.
It is
Sir,
the
settings
date
for
and
date and
time
time.
updated all.
Yeah,
You don't have to be
true.
setting time date time on.
Yes, like the date and time. Okay, that's okay. Then on top of the motherboard, we also have what we call the expansion slot. The expansion slot. I don't know why. Please, I'm sorry. The expansion slot. You know that most motherboard have one or more expansion slots. It depends, and there are types of expansion slots. Sometimes it can be white. Mostly it's like white, and it has also some narrow or PCI slot on the board. Sometimes it can be black or narrow or PCI express or slot. So you are seeing that you might also see some large. Sir, please, I'm coming. I'll be with you. Sorry, just in a moment. One, two. So that's the expansion slot that you have. So please, you can see from the typical motherboard like this one after you can see the expansion slot. You can add a lot of functionalities to your computer. And then most of the laptop, the motherboard comes with what we call the expansion slot for you. Please take your time and also get moved. Then we also have what we call the port and connectors. The motherboard also holds for the port and connectors. There are a number of ports at the back of the motherboard connect with the keyboard, the mouse, and the other devices. So the port and connectors. So we have the serial port and what the parallel port in this. We have the serial port and the parallel port. I'm going back. And in front of the serial port, we have the COM1 and the COM2. Some of these things, they are no more in the market. The serial port on the back of the motherboard are one of the two types. So we have the DB9 mil and the DB25 mil. The serial port with what 9 pins, and the DB25 mil is what a serial port with what 25 pins for you. And then we have the parallel port. The parallel port, we think that is also another type of what connector on the back of the motherboard, and mostly the printer do that. But now we have replaced all these ports with what we call the USB. Now most of these ports we don't see it here. So this is an example of the parallel port and the serial port. Now, if you look at the current motherboard or the current computers, they come with what we call the parallel. They come with the USB without the parallel port and the serial port. So let's get to know that. Then we also have the video adapter. The video adapter. I will end here. I'll have some other assignments. So please, the rest we are going to read next week. We will continue from there. Is that okay with me? I want to end here. It's like with some 10 slides or some 15 slides. So please go and read that next week. If you don't understand anything, you can ask questions on that. So I want to end here. Any question? Hello? Are we there?
Yes, sir, we are here.
Yes, sir.
I said I'm going to end the lecture here. Take this time and I'll send this to the course right now. So after that, you can go through and read it. It's left with about 10 slides. If you don't understand anything, you can ask your question next week. So without saying anything,
Please,
yeah.
Okay.
Yes.
Please, you have about 8 lecture notes. Are we covering everything or selected?
Please, that one, don't ask me that question. We will do as much as we can. Wherever we get to, I'll send the question up to that point. So I can't answer that question up to now. It's better you read. So I will not be selective. You have to read everything. But when it's time for me to set the exam questions, I'll tell you where I'll cover up. But for now, let's go through the materials. Are you okay with that?
Yes, sir.
Okay, sir.
Yeah, so don't worry. Yeah. Okay. Bye-bye. Course rep, send me a hi on WhatsApp so that I can send it to you right now. Bye-bye to
Yes,
all of
sir.
you. All the best.
Please let us all try and join the community so that we can have all the slides in the community rather than having everything on the group page, which is kind of flattening it. So let's please join the community and have
Please,
everything on the community. Thank you.
Send me a message right now on WhatsApp. I can send it to you right away.
Yes, sir.
Okay,
Yes, sir.
I'm waiting for you. Bye bye.
Yeah.
I'm doing something. Sorry.
Let us please try and join the community. I'm begging all of us. Let us try and join the community so that we can have the slides in the community rather than having everything flooding the main page. Thank you.
Also, please do they sell kinky in the community? If not, for me, I won't come on.
Try and join for me. Thank you.